Good evening, everybody. Today is day 16 of Math 133. We are going to talk about the Chapter 7 review, which you'll find in your course pack on page 457, 457. So you want to get that. Uh, Let's see. What other things do we need to talk about? So I emailed out the key for the midterm, as you guys requested. So take a look at that. See if you have any questions on which ones you got wrong. So if you're not sure which ones you got wrong, I mean, you can compare to your previous test, but you can also reach out to me. I can go over how we get those answers. Um, so yeah, I emailed that to you, so make sure you take a look at that. If you took the test at the testing center, I have your test, but you might not have a copy of it. You don't have a copy of it. So if you don't remember what you put down, let me know and I can email it to you, so you can compare your test to the key. Okay. Um, but we can also go over any questions you have on the midterm, after we're done with the Chapter 7 review. Okay. Um, okay. What else? So, uh, in a couple weeks, so not next week, but on Tuesday, March 24th, we're going to do a candy project. So, you're going to need to get some candy. So, uh, I sent a email or sent a message in Remind, indicating what you need to get. So this is what the project is going to be. So we just need to write down how many we have of each color in your bag for M&Ms and Skittles. You need to buy some M&Ms and buy some Skittles before March 24th. Okay. So you're going to hear me say a lot throughout the rest of the semester. The bigger your sample size, the more accurate your predictions are going to be. So we need to have a reasonable size sample. So you need to have buy enough candies that your data is going to be accurate. So you need to buy around 50 candies. Now, you can't buy 50 candies. So you need to buy somewhere around 3 ounces or more, at least 3 ounces. So if you buy M&Ms, you can buy whatever you want. You can get the boring plain ones if you want. But I like the peanut ones. Actually, I like the peanut butter. That's the ones I'm going to probably be getting. But you could also purchase, I think they have almond and pretzel. Um, so as long as you get these colors, so don't buy like the Easter bag where it's like white and pink or whatever, right? We need just the normal colors. So uh yeah, the normal chocolate, the just plain ones are boring, man. I don't know. If you want to get those ones, that's fine. So the normal size bag is 1.5 ounces, so that's not big enough. So if you buy two of them, that's fine. Uh, if you if you get a 3 ounce bag, that's fine. I'm gonna probably buy a 5 ounce bag. Um, uh, if you buy a huge bag, like 3 pounds, that's going to be a lot to count. But you're going to be super accurate. So maybe cut it off at a pound. I mean, it's fine if you want to buy a 3 pound one. Like I said, your data will be super accurate. So um, anyway, so somewhere between 3 to 16 ounces. So, um, we don't usually tell people to buy the candy at the start of the semester because, it gets eaten. We don't want your kids or your spouse to eat your homework. So, yeah, anyway, so that's why we waited until after the midterm to tell you. So anyway, you're also going to need to buy some Skittles. Same thing, somewhere between 3 to 16 ounces of Skittles. Uh, and unfortunately, it needs to be in the red bag because we need these colors: orange, green, yellow, purple, red. Um, so chapter 11, we're going to look at both bags together and look at the colors that match. Okay, so uh, because of that, you can't buy like the tropical one or the wild berry ones, even though those are better, right? So, um, I think that's that. Um, If you don't want to buy candy, that's okay. There are a couple of like calculators that can give you a random sample, and I can show you how to do that if you want. Not on March 24th, so make sure you get a hold of me before that. So yeah, um, I'm not sure if Cindy is joining today, so I don't think she is. Sorry about that. Uh, okay, so that's all about the candy. Talked about the midterm. Um, okay, I think we are good. So, like I said, I messaged you and remind on that. So, okay, so chapter 7 review is going to be on page 457. Page 457. And chapter 7 is all about the normal curve. Okay. Normal curve is a bell curve. Okay. It kind of looks like a bell. Um, it is one of the most famous distributions, if not the most famous, and it's definitely going to be the one that we are going to be using throughout the rest of the semester. So the normal curve has a mean of 1 and a standard deviation of 0. We are going to be focusing on mean and standard deviation for the rest of the class. So you'll remember when we were looking at skewed distributions. Yeah, mean of 0 and a standard deviation of 1. When we were looking at skewed distributions, we said that you want to use median and interquartile range because they're resistant to outliers. We are going to be abandoning median and interquartile range, and we're going to be focused on mean and standard deviation the rest of the class. Okay. So uh, with that in mind, we want to make sure our data is not skewed. Okay. Um, and yes, you're right. The normal distribution is a mean of 0 if we're looking at z-scores, okay? And a standard deviation of 1 if we're looking at z-scores. You are correct, Gabby. So um, we are going to be looking both at z's and x's today, and we're going to be using them kind of interchangeably, but they're not exactly interchangeable. So we need to keep that in mind as we go through it, okay? Um, anyway, so chapter 7 is all about the normal curve, but we're going to be using the normal curve throughout the rest of the semester. So chapter 8, we're going to talk about taking multiple samples and how that lands in a normal curve. We're going to be looking at using the normal distribution when we're doing our confidence intervals and our hypothesis testing in chapters 9, 10, 11. Okay, so definitely an important piece. Okay. Okay. That all said, it's important to be able to tell if your data is normal or if it's skewed or if it's in some other distribution. Okay. And so one of the ways you can look at it is doing what's called a normal quantile graph. Um, you're basically taking your points and placing them where they should be in a normal distribution. And if you end up with a strong positive correlation, okay, for your linear coefficient, then that means that this data is probably from a normal distribution, okay? Um, on the other hand, if you have outliers or if the shape is like this, then it's not a normal distribution. Now, we're not going to be building any of these quantile graphs, but we are going to be using them. Okay, but I'll show you how they would work. So you'll remember for Tuesday, we looked at home runs from 2019, right? We looked at this for our Chapter 7 project, and we did a bunch of stuff, and it showed that the distances are pretty close to a normal distribution. Okay. We graphed it on a histogram, right? And then we have the normal curve. So let's take a look at what a quantile graph would look like for this. So you don't need to follow along for this. I just wanted to pull it up and show you. So it's this guy right here, a QQ plot. And if I graph distance, you'll see that it plots where the dots should be if it was a normal distribution, and it's pretty close to a line. There's a couple of outliers down here. You'll remember we had that 251-foot home run that we pointed out might have been an outlier where maybe that's an inside the park home run. Couple of outliers here, but I would say that the vast majority of this data lies on this line. So I would say that this is a normal distribution. Okay. So anyway, if none of that makes sense, that's okay. We haven't actually started on our review. So yeah, so that's
You
that's
still
uh
under
that's
this.
what a quantile normal quantile is. Okay. All right, let's look at number two. Consider
Okay,
these
Connie,
normal
you can go.
curves. Oh, hi Cindy, how's it going? How are you this evening?
Sorry, Joe. I am on
Oh,
my iPad. I cannot get on with my computer for some reason.
oh,
Oh, now it's
well,
now it is.
now it is. Okay. Well, you are not the first person to ever have internet issues. I've I've been lucky this semester. We had at least one class last semester where my internet just fell apart, and I was like, I can't teach today, guys. Sorry. So Cindy had to help me. So, all right, number two. We have four different normal distributions here. Which graph has the largest mean? So the mean is the middle, okay? And if I draw down to here, this is where my mean would be, my X bar, or I guess it wouldn't be, it might not be X bar, it would be mu, okay? On this X axis or this Z axis, right? And on the X axis, we have large numbers to the right and then small numbers to the left. So really what we're looking for is which of these is uh, furthest to the right, okay? Which has the largest mean, okay? Which of the curves has the largest standard deviation? So that's going to be which one is the most spread out, okay? Uh, so all of these here are normal curves, and the normal curve underneath of the normal curve is an area of 100%, right? If I took some paint and I colored under each of these normal curves, I would use the same amount of paint for each one, okay? So the standard deviation, you'll remember, is how spread out your data is. We had three different ways that we measured spread. There was standard deviation, there was range, and interquartile range. So if your data is very spread out, it's going to be the widest. Okay, so whichever of these is the widest. And also, if it's wide, then it's going to be short. Okay, so the widest and shortest is going to be the one that has the largest standard deviation. Okay. Right now, I'm just giving hints. We'll go back through and we'll answer which one is which in a second. But for now, I just want to make sure that we have some hints written down. So for number three, find the following for the standard normal curve for each part. You have four decimal places, write P of X notation from StatCrunch, circle the answer, shade, and label your graphs. So this you'll find on page 257. Right now we're on page 458. Sorry about that, page 458. On page 257 in our exam notes packet, there's information about chapter 7 and how you do the stat crunch for it. So it's stat calculators normal. We're going to be doing stat calculators normal all day today, okay? And not just today. As I mentioned, we're going to be using the normal curve throughout the rest of the semester. So stat calculators normal, okay? And when you're in there, there's four different things that you might need to do. You might have a z-score and need to find the area. You'll remember that um, under the normal curve, if you're within one standard deviation of the mean, so if your z-score is between -1 and +1, you're looking at 68% of the data. So 34 is here and 34 is here, that's 68, okay? So each z-score, 1 and -1, has a corresponding probability that goes with it. Two standard deviations is 95% of your data, right? And three standard deviations is 99.7. So um, we're going to be looking in chapter 7 at looking at other numbers, like let's say I wanted to look at 1.5 standard deviations, a z-score of 1.5. Or what if I wanted to look at a 90% probability? How many what's my z-score for that? Okay, so that's what we're going to be doing with this chapter 7 stuff, where if I have a z-score, there's a corresponding probability that goes with it. All of these things here, area, percent, probability, proportion, percentile, they all mean the same thing. Okay, it's a number between 0 and 1, right? Probabilities go from 0 to 1. And so if you have a z-score, you can find your probability. If you have a probability, you can find your z-score. Now, sometimes you won't have z's, you'll have x's. And in that case, you can still do it. It's the same thing. The only difference is instead of a mean of 0 and 1, you'll have to put in your mean and your standard deviation. Okay. Otherwise, we're going to be treating x and z very much the same all day today. Okay. Okay, so page 257 for all of these. Okay, so stat calculators normal. By the way, this one for percentile, when you see percentile, we always round down. Okay. In our class, normal math rounding rules apply except for two cases. One of them is for percentiles. For percentiles, we always round down. The other one is for sample sizes, which we haven't gotten to yet, but sample sizes we always round up. And I'll point that out when we get to it, okay? But percentiles we round down. Question 4, we're still going to be using stat calculators normal, and we need to find these three values, okay? Every z-score has a corresponding probability. So if I have this z value, I know it says x, but these are these are actually z values because I can tell that because my mean is here at 0. It's centered at 0. So since every z has a corresponding probability, we would just do, the page 257 stuff, okay? So when you're doing these kind of problems, it's not always clear which one to start with. I can't start with these two because I don't know my probability and I don't know my z. If I don't know either of them, then I can't start with that. I'm going to do this one first. And then once you have that, you can find this one second and find this one third. Okay. So you want to start here. How do you find this one? So A1 plus A2 plus A3. If you add those together, what do you get? Does anybody know? If you add this plus this plus this. So this shaded area plus this white area plus this shaded area. Mike and James, you guys got it. It adds up to 1. It adds up to 100%. Okay. So once you know this one and this one, you should be able to find A3. Okay. And that's because the area underneath of a normal curve always totals 1. Okay. All right. Question number 5 on page 459 is very much similar to number 4. You have 3 different numbers that you're looking for. The difference here is I'm not looking at z values now, I'm looking at x values. And I know that because my center is no longer 0. So you just have to make sure that you're putting in your mean and standard deviation, okay? Still going to be looking at page 257, but this time you're going to use number 3 and 4 where you have x values or you have probabilities and you're trying to find your x values, okay? By the way, for this one, uh, which one would I want to find first? A1, X1, or A3? Yeah, you're going to find A3 first because you have a corresponding X value. You can't find A1 or X1 because those two relate to each other, but you don't know what either of them is, okay? So you find this one first, okay? And then A1 plus A2 plus A3 equals 1, okay? Provide an interpretation of X1 and A1 using proportion Provide an interpretation of X2 and A3 using probability. These two are pretty much the same. It's just a different way of writing it. You can write it either way. So for proportion, you would write blank percent. You have to find what it is. Blank percent of all Americans drank, and then fill out the rest. Okay. By the way, I didn't read this. So the amount of water adult Americans drink per day is normally distributed with a mean of 44 and a standard deviation. So that's what we're talking about here, how much water people drink. This question always reminds me, I've got to drink more water. So, okay. Um, Down here, writing it with probability, you would write if we select a random American then the chances da 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 and fill in the rest. Okay. All right. We'll come back and we'll fill in the rest there. Okay. All right. Question 6. The average daily jail population in the US in 2022 was normally distributed with a mean of 652.5 thousand inmates, standard deviation 59,000, four decimal places, whole numbers for x's, right p of x. Okay. Um, all right, so still looking at page 257, okay? Um, Interpret the value found in part A in the context of the situation. So we need a direction word here. Okay. I forgot to mention on these ones, 5, B, and C, you also need a direction word. So that would be more or less or between. Okay. You need to use one of those words for both B and C. Okay. Same thing here. Interpret the value found in part A in the context of the situation. You need a direction word. So you can do it either using proportion or probability. Either one of these is fine. Okay. So you can say blank percent of the blank, blah, blah, blah. Or if we select a random blank, the chances are either of those is fine. Okay. Um, okay. And I think that's all the hints. So let's jump back to page 457.